This is Shakil Ahmed. In this tutorial, we will discuss about analyzing the data on Likert scale. The most important thing is to first check the reliability of a questionnaire. The data on Likert scale is usually scaled from 1 to 5, 1 representing strongly disagree and 5 representing strongly agree, or strongly dissatisfactory to strongly satisfactory, or even in medical studies we have pain scale data, very low pain to high pain, or we can say the uh, very uh, poor health condition to a very good health condition. We can scale like that. So such kind of data should be analyzed very carefully as we have them on ordinal scale. So here is an example I have taken from Kaggle. This is data on self-esteem scale responses that consist of 10 questions related to self-esteem. How do you feel about yourself, basically, and as compared to other people, and whether you are able to do something like other people. So these are related to self-evaluation of a person. So let us first check whether uh, there is a the questions are reliable or not. The questions are reliable. Reliability means whether the questions are producing the outcome which we want to, which we really want to produce, or the questions are not mirroring the thing, or it's going in different direction. So when we have a set of items, we need to check whether they are going in same direction or not, whether they are producing the intended outcome or not. So we have library psych command, psych library that I have installed, and I'm just taking the first 10 items, although in dataset we have other variables as well. You can see that data frame. So we have uh, 17 variables consisting different questions. Only 6 variables are showing. Uh, 4 variables are representing here, and 13 more variables. So let's check whether these variables are producing the same outcome or not, or these questions are reliable or not. Let's start with psych command that consists of uh, alpha sec, then double colon, then alpha, and the I have just written data in data frame as the data is in form of tables as I have downloaded from Kaggle. So I have just converted it into as dot data frame, just convert into a data frame. So these are the results we can see. You can see there are negative correlations. It means some questions are in reverse direction. For example, they are for if some question is in one direction, then the other questions are in different direction, in opposite direction. So we are getting negative value of the Cronbach alpha. You can see this is the summary. The raw alpha is minus 0.17, and this is standardized alpha, and this is squared multiple correlation that is also measured the correlation between the variables. The raw alpha basically measures the correlation between uh, all the variables, and this is the average correlation, and this is signal to noise. Signal to noise means the variation between uh, questions and divide by variation within a question. So this is the average standard error, and this is the mean, and this is the standard deviation, and this is the correlation. So these are the correlations when this is the confidence interval for alpha, lower confidence interval and upper confidence interval. Usually, a value of alpha between uh, zero point 0.7 and above is acceptable, and if it is zero point 0.8 or greater, it's very good. So these are the ranges you can see here. Alpha less than zero point 0.6 is very poor, but in our case it's negative. It means some questions are measuring on opposite direction. So for this, we can check. First, we can discuss this result when we drop some variable. These are the results. When we drop this variable, we get this result, and when we drop second variable, we get this result, and so on. And this is the item-wise summary statistics. Basically, this is the number of observation in this item, and this is the correlation between this item and all other items, and the sum of the items. And this is the standardized correlation, and this is the correlation adjusted for variance, and this is the correlation when dropping the variable itself from the sum, and this is the mean response, and this is the standard error of the response. As we have data on 0 to 1 to 4, the mean response is 4, although we prefer to find the median in this case, in case of ordinal data, but the software is producing mean. So here we have some variables are in the opposite direction, so we can use the check keys command. Check key is equal to true. So we are doing the same thing with check keys is equal to true. So here we can see uh, some items were negatively correlated with the first principal component and were automatically reversed. Means they are just changed. So those variables are multiplied with minus sign. So they are just giving the result in the same direction now. You can see now the values are all the values are positive, and now the correlation Cronbach alpha is 0.91, and these are the other values. And we can see if we remove the item, that is if we remove this item, it will again give the zero point 0.9 for alpha, and the standardized alpha with zero point 0.9. So these are all the results, and these are item wise correlations, and these are the non-missing responses frequency for each item. For each item, we have frequency of non-missing responses. Uh, we have no, 0 and 1 non-missing responses, 6% in 1, and 18% in 2, and 44% in 3, and 32% in 4. So in most of the studies, you can just copy this table and just report in your thesis or in your publication, whatever you are going to present. So this is the main result, and there is no missing value in our data set. If some values are missing, then it will show the details in this last column. So now this is the result, and you can see these the variable in negative order, basically in reverse order, are just converted to again to the same order as the other variables, and a negative sign is attached to those variables. Inclined to failure, this response to this question is this question was in reverse order, and similarly don't have anything to be proud of. That is also in negative. So whenever doing an analysis, you first do a pilot analysis and you can check the variables with some problems, and then you can rewrite or reconstruct your variable or change the statement of the variable, the question before doing your final data collection. So that's all about the Cronbach Alpha. Thank you.